The transpose of matrix A denoted, can you guess how we denote a transpose? How would you write it though?
N by N.
Oh, you're really thinking. How did we write the transpose? How did we denote? How do we write it down in symbols, the transpose of a vector? Superscript t. It's not raised to the t. This is not A taken to the tth power. There is something called matrix exponentiation. It comes in when we do square matrix multiplication by itself many times. There's very powerful in linear algebra. This is not exponentiation. We're just putting the transpose in the superscript. How big would that matrix be?
N by N.
So the transpose actually flips dimensions and is formed, the transpose of A denoted by is formed, there we go, is formed by doing what? Turning all columns of A into rows of A transpose and vice versa. Let's get specific. Let's use our operators from lesson 8 to do some work. The situation that we have now is, let's imagine we're going to form the transpose. So let's form A transpose by columns. And we'll do it in all three ways. From that standpoint, let's remember, how big is A transpose? We know that A is an element of mango times November, which means that A transpose is an element of November times mango. How many columns could I have there? If I'm going to form this by columns, how many total columns do I have? Yeah, I have m of them. So let's let the column index k, we're always going to use, I'm going to do my best to use k for column index. And let's go ahead and form column k of the matrix A transpose. Can somebody named Namanja give me the MATLAB notation that would pull off column k of that matrix? Damn! What is column k of A transpose? How did I form the transpose matrix? Column k of the transpose came from row k of the original matrix, and now I'm going to ask you to do something crazy for me. Does that equality make sense? Better question. How big is each column of the transpose matrix? Must be in n by 1. Why would it be in n by 1? Because each column has n rows. How big is this matrix right here as written, or this vector, I'm sorry? Well, row k of A, how big is A? M by n, so every row has n columns. So formally speaking, unless I do something creative to this thing, this is a 1 by n. Can I ever say that an n by 1 equals a 1 by n? No. That's called sinning. But, what did you tell me? The moment I can drop this thing right here on this, then what do I know? Row k of A gets turned into a column vector and stored in the kth column of the transpose. And another way to write this in MATLAB notation, Nikki, I know you expected that. Remember, the transpose is happening afterwards. How do I pull off row k of the matrix A?
K, comma,
Nice. And then transpose. Awesome. And that was for all k going from 1 to m. That constructed the transpose matrix by column, because we literally constructed it column by column. And the way that we did that is to take the first column, we take the first row of A, turn it into a column vector, store it in the first column of the transpose. To get the second column vector of the transpose, we take the second row, turn it into a column via the transpose, and then store it in the second column of the transpose. What if I wanted to form a transpose? Can you guess what I'm about to write? What would I do? Well, instead of moving through the columns, what would I do instead? Move through the rows. If I use k to identify columns in this class, what do I use to identify rows? I, and then I use j for auxiliary indices. So if I use an index that I don't actually plan to store in a row or column, I'll use j in it. Or sometimes I do intend, but I just do that. Let's go ahead and say that I is in, how many different rows do you have? N of them. Now if I look at row I of the transpose, and maybe I can ask for Kitana's help. If I wanted to do matrix colon notation in order to pick off row I, what would that be? What comes first, rows or columns? Yeah, you got it. I comma colon, and that's of the transpose matrix. How do I pick off row I of the transpose, Arash? Row I of the transpose comes from doing what? Yeah, it is a row partition, but what is row I of the transpose? What is the transpose again? What do I do to form the transpose? I take A, and every row becomes a column, and every column becomes a row. So if I want to know, if I'm looking at the transpose and I'm looking at row I, how did I get that row? Well, I took column I and then took its transpose. So in this case I would have, this is going to be column I of the matrix A, but the problem is column I of the matrix A has size m by 1. Row I of the matrix A transpose has size 1 by m. So these two things have to be the same size if they're equal. What can I do to make them the same size? Take the transpose. This is the really nice thing about those operators. What's another way to write that particular column in MATLAB's colon notation? And I might ask Christian on that one. How do I pick off column I of the matrix A using the MATLAB's colon notation? What comes first, rows or columns? I'm asking you to form columns, but when I'm thinking about matrix dimension, what does m count? The number of rows, and n counts the number of columns. In this case, the first index identifies the rows, and the second index identifies the columns. Which column am I looking for? So I'm looking for column I. Out of column I, which rows am I going to take? Yep, all of them. And then I want to make sure that that vector is actually in the form of a row, so that I have to transpose it. So far we've done the column by column partition, we've done the row by row partition. What's the one other way we've seen to define matrices, Marvin? Column by column, row by row, and entry by entry. That's the most painful one, right? Let's go ahead and form the transpose entry by entry. We're not going to do it like we did the other ones. Not unless you want me to. Right? In order to do it entry by entry, I actually would need that I represents a row. So how many rows do I have of the transpose? N of them. And I would need that K represents a column. If I looked at entry Let's go ahead and take the entry operator. Ik of the matrix A transpose. How would I do that in MATLAB notation? I comma k. What's that equal to in my original matrix? Give myself a solid F for board management on this particular. You want to see someone cheap? Call it quick and dirty, right? Should make an operating system. Call it DOS. Thank you for the one person, two people, I suppose. What would I do to get the ikth entry of the transpose? Where would that come from? If I'm looking in row I and column k of the transpose, where does that come from in my original matrix? Row k, column I. Because literally what I do to form the transpose is I just do... Yeah, that's one way to say it. Yeah, that's a really sexy way to say it. This would be ki. Right? Ik swaps to ki. That's right. That's one way to think about it. You can think about taking the diagonal element and then reflecting.